Cool. So we're from Orb. We're going to do two presenters. So I'll start. I'll kick us off. I'll give some background on Orb and why we started Orb and what the kind of context of building the company is. I'm Kshitij. I'm one of the co-founders, and then Arsh is an engineer on our infrastructure team. He'll do a deep dive into a specific problem that we solve that is particularly relevant to the infrastructure skill set and part of the product. So I guess the first interesting thing is, as you've seen in some of the other talks today, billing is super critical, but there's already a lot of billing providers out there. So I think one of the first questions people have, unless they're talking to us in a sales conversation, by that point they're already convinced they need a billing vendor. But at least some people have this question of why did we build another billing vendor, and what are even the challenges with usage-based billing? And I guess I had the skepticism myself as well. So some of the motivations for building Orb, I was previously at a company called Asana. Asana does enterprise productivity, task management. Asana spent many years working on billing systems. Asana was previously on one subscription billing system, moved over to a billing system called Zuora, but still staffed, I think by the time me and my co-founder left, something like 5 out of 25, or maybe a little bit more than that, product and engineering teams on just billing and monetization. Super impactful for the company, especially as the company was growing and the business was growing, but a very heavy engineering staffing problem. And Asana, as maybe some of you know, actually has relatively simple billing. It's billing on seats and licenses. So once we kind of left Asana, when we started talking to other infrastructure companies, we realized they have a much more basic problem, which is just being able to calculate and charge their customers accurately. Required not only the expertise in the billing data model and the needs of the business, but also a bunch of data infrastructure work. So that's kind of seeing that play out was one of the motivations. And then specifically just looking at other billing tools in the market, things like ChargeBee or Recurly or Stripe Billing, we saw they weren't actually much of a good fit for usage-based billing, and we'll talk about why that is. So let's talk a little bit about some of the technical challenges that we've seen when we are building Orb, but just generally guiding a lot of our customers through usage-based billing. So at Orb, we work with companies like Vercel and Pinecone and Perplexity, and so typically these companies tend to be in developer tooling, cloud infrastructure, data space, and then nowadays, of course, also AI, which falls into one of those categories typically. So the first thing here, of course, is just complex business logic, right? Billing is a very complicated domain, and that complexity unfolds over time. This is typically manifests as something that starts simple. Maybe you have a couple tiers. You're billing on a few different metrics. Maybe you're a cloud infrastructure company or a database company, and you're billing on network and storage and compute. You have standardized ways of calculating these things. And then your sales team comes along and says, hey, we have this one customer, they want this different way that they want us to charge them, or we're actually going to give them this discount that lasts for the first 3 months of their contract, or actually we're going to allow them to pre-commit some dollar amount of usage on our platform. They can draw that down over the course of 2 years, but then once they draw that down, they're going to have a specific overage rate. So you kind of have this story time and time again where things start simple and then they get more complicated very quickly. And that can be on the kind of edge case of enterprise customers, but that can also happen quite frequently, even with your self-serve plans, as you go from maybe a free and a paid plan to many tiers, to add-ons and bundling and unbundling. That's a story that we've seen, and it gets very hard to, just even from the domain model, re-architect your system time and time again, every time you're rolling out a new SKU, or again, your business team wants to change pricing in one way or the other. The other thing that we found, which has been interesting in building Orb, is that there's a lot more to do for customer experience. Typically, when you're thinking about billing with subscription seats, you have this admin portal, people can upgrade, downgrade, maybe they can change the number of seats. But with usage-based billing, typically, as you can imagine, customers want to know how much have I used so far? How much have I accrued? Have I hit a spend limit? show me a graph of my daily usage across all metrics, show me my burn down of my commitment. So there's a lot more surface area between you as a SaaS application and the customer. And so we've found that actually, instead of selling Orb primarily to finance teams, a lot of the times our champion or stakeholders within product and engineering. So that's been a pretty drastic shift in terms of who's thinking about the billing problem and who's owning it and who's maybe championing either building it in-house or buying a vendor. The third thing is changes. So billing providers are shockingly bad at this. They'll give you the way to implement your pricing, but then now when you need to change it, the prescription is almost always, okay, write a script. And you write a script and you figure out like, okay, here's all these subscriptions, they're on this version of price, I need to move them to a different version of pricing. I need to make sure that the script runs before midnight because then their billing period is gonna take over. And then, oh wait, some of them bill on the 1st, some of them bill on the 10th. And you kind of get this mess of change management. And it is usually for a lot of businesses coincides with a launch where there's already a lot of pressure built up around rolling the thing out. And now you also have to launch new pricing. And I'm sure we've seen on social media, there can be a lot of backlash to new pricing, right? So we'll talk about how, a little bit about how Orb implements this within the product, but in general, this has been a big pain point. And with usage-based billing, when you have so many different dimensions, it kind of amplifies this problem. The next thing here is just usage-based billing, as I was saying, is more of a data infrastructure problem. We candidly work with teams that have a lot of expertise in building really reliable, high-throughput systems, but typically the people who really enjoy doing that at any given company don't really want to apply that to billing, but in a lot of ways, we've had to build a lot of in-house expertise around being able to run large-scale queries with very low latency, and Arsh will talk a little bit more about that in the deep dive, but that's been a big part of building Orb and the challenge. Just for some context, we have individual customers who send us hundreds of thousands, if not significantly more than that, events a second. And as you can imagine, these are cloud infrastructure companies where they're generating those events, and they still need the deduplication guarantees, they still need the make sure that you're billing for it in the right time range. There's still a lot of precision involved because ultimately it is revenue data that needs to stand up to audit. And then finally, speaking of audit, usage-based billing complicates the accounting story quite significantly. So I don't know how many folks are familiar with or maybe have the misfortune to be familiar with technical accounting, but the basic principle, right, you need to recognize revenue as usage happens. This gets very, very tricky when you have things like prepaid commits and when you have billing periods that aren't aligned to accounting periods. And now all of a sudden, you have these much larger companies like Snowflake where they've talked publicly about having a lot of data scientists on the team, which makes sense because on the finance team, because now this becomes a data exercise and something where you need to be able to understand how usage is accruing for every customer, for every SKU each day, and just looking at the invoice at the end of the month is no longer enough. So that's been some of the challenges that we've tried to tackle on this journey. So here's a basic schematic of Orb, and then we'll go into a little bit of a demo, and then Arsh will go into a little bit of a deep dive. So what we do is we take usage events, we have a usage tracking module that aggregates these usage events with metrics. You set up your plans and pricing in Orb, and then we are both a billing provider, so we're a replacement for something like Stripe billing, and an invoicing provider, so we will generate and deliver invoices to your customers. And you can also plug in a payment processor like Stripe in order to charge against those invoices. So we don't process payments, but we do issue invoices. Let's just skip this, we'll go straight into the product. Hello? Okay. So I'll make this relatively quick, and then I'll actually switch to Cloud Infra here. I'll make this relatively quick. One reason why I'll do that is this is available if you all are curious on our static site, demo.withorb.com. This isn't like an internal data environment or anything, so you can go check this out. But I'll kind of walk you through some of the core abstractions because I think they hit on a couple of the pain points I mentioned. So typically I start with events. We work with customers, as I was saying, who send us events at very high scale. Events are actually pretty simple. So includes some sort of idempotency key for deduplication, an event name, some customer identifier, and then a bunch of key value properties. So don't have to specify the schema of these up front. These can change. They typically do change over time. But one thing you'll notice is you're not sending to Orb a final quantity, right? You're sending to Orb some structured event, and then within Orb, you're taking that and transforming that into something that you want to charge your users, some aggregate that Orb is responsible for keeping track of. The interesting thing about that is you can have many events that all roll up to the same metric, or many metrics that all operate over the same event stream. And that additional layer of abstraction is typically very useful compared to something like Stripe billing, where effectively you're giving a periodic quantity update, and all of the data architecture work, the data infrastructure work has to happen outside the platform. So let's talk about metrics. In Orb, you define your metrics as something that your users would understand as an aggregate that they're being billed for. Of course, you're probably familiar with this from a bunch of BI tools. You can do that with a drag and drop UI, add conditions, figure out how you want to aggregate over properties of the event, all pretty simple. One of the things we've found as we've been selling to engineering teams is they don't want to be limited to a set of dropdowns, unsurprisingly. and so you can just write SQL in the platform. And I think this is one of the things where, yes, there's real technical work required in order to enable this, but a big part of this is just who's the consumer of the product, right? Like with engineering teams setting things up in Orb, it makes sense for them to write SQL. It makes sense to them that I'm familiar with how to do this. I can take an event, pump it into Orb, set up a metric, and now start using that as part of my billing setup. Once you've defined your metrics, you define plans. Plans are template pricing that, maybe you're subscribing thousands of people to the same plan. And a plan consists of some number of usage-based prices and fixed fee prices. So usage-based price is something like a compute or API request, something that's tied to a metric, and then a fixed fee price is like support, platform access, seats, something that's not tied to a metric. So just to kind of round this out and jump to what it looks like for an active customer, and then I will let Arsh talk about some more of the technical stuff. Here's an active customer in Orb. Again, very different than what you might see in a traditional billing system. You're seeing Orb keep track of their usage over the course of the month so far, and how that metric has changed. Of course, typically this data will be consumed through the API and then further exposed to the end user. So you'd want the same internal visibility, ideally, that you give to your end user. Bunch of stuff around prepaid credits, and then finally, this idea of a draft invoice that's accruing, which, as you can imagine, is important for mid-period visibility, but is also important for things like accounting, where you need this data in order to potentially recognize revenue as it's happening. And again, this idea, like an invoice in this world really shouldn't be just a quantity unit rate amount. It should show you a lot more visibility on each line item. What are the trends? Maybe if you're breaking down your usage by region or cluster size, for example, it should give you that visibility. So that's a big part of why we've redesigned the invoicing layer as well, because ultimately that's a very important touch point between SaaS applications that we serve and their customers. That's all I'm going to do for the demo. Maybe I can take questions at the end, but I saw a hand, so I'll take one question and then we'll take more at the end.
So the one thing I'm thinking about is that like a huge issue when you do this kind of billing is suddenly in the middle of a day, you see a huge spike.
Yeah.
What kind of alerting do you send out for people?
So that's Arsh's deep dive. So he'll talk about alerting and spend caps. And
thanks for setting me.
Cool. Yeah.
Cool. Thank you, Kshitij. Can you guys hear me? Okay.
Yeah.
Cool. I guess I got a double whammy set up there, so appreciate it. But I'm going to be talking specifically about how we technically solve what we believe is one of the more challenging problems when it comes to actually offering a usage-based product that is supporting low latency alerting on a high cardinality usage data set. Specifically, we've seen kind of two different shapes of alerts. There are usage-based alerts where you have a specific metric, maybe it's like your compute hours, or you have cost-based alerts, which are like, I need to know what my total running, my running total for an invoice is over the current billing period. Think of these kind of like, your usage-based alert is like a Datadog monitor on a specific metric, and your cost alerts are very akin to like Sentry spend caps. Hopefully that makes sense to most of the people in this room. Cool, so just to talk briefly, and I'm gonna probably go through this slide very quickly because Kshitij just talked through a lot of this, but every event maps to a quantity change on a metric or a set of metrics. You can use groups of these metrics to create plans. Plans are basically your contracts. You can subscribe specific customers to a plan or a set of contracts, and every single one of those customers will have an invoice for that plan. And then we support alerts on top of that. So you can have alerts on specifically one line item's usage, or you can have alerts on the total invoice cost for a billing period. So about a year ago, here is how we solved the first cut of this, and it looks, yeah, great. I'm gonna try and figure out how to point for you, but maybe it'll work pretty well. But on the left there, you have our events data store and what we call our billable metric values cache. So those are the two pieces of, or the two data stores that will serve those metric quantities that Kshitij showed you on the invoice. We've localized a lot of the complexity in running those complex SQL queries into what we call the billable metric computer. Then we run, so then we have two different services that both feed off of the billable metric computer. We have what we call the alert evaluator. This fetches an alert to evaluate. It'll request from the billable metric computer the usage quantity for that alert, and it'll determine whether or not it needs to fire. The invoice issuer will periodically go ahead and determine when we've crossed the billing period for a specific customer. It'll go ahead and recompute all of the values just to make sure we got every single last event, and it'll go and issue the invoice. And then optionally, if you set up Stripe payments or maybe a sync to an additional invoicing provider, we'll go ahead and sync the invoice externally as well. Cool, yeah, so there were some drawbacks here. I think mainly we're gonna focus on the alert evaluation piece here. One of the things that you can probably tell from this diagram and what I just explained was that we basically implemented like a polling batch-based process. We have a large table, we have a set of alerts, we query for one alert, we evaluate it, we move on to the next one, so on and so forth. This obviously causes problems as your platform grows, and that's kind of what we noticed. So there were three main problems that we found. The first was we were wasting a lot of work. Our billable metric quantities only really change when we receive an event. But because we've decoupled the actual event ingestion piece from the alert evaluation piece, we had no idea whether the alerts we were evaluating and then iterating on were actually useful or not for us to be doing. The next thing we realized was that the smaller customers on our platform were being starved. If you have, 1 to 2, maybe 3 or 5 really large customers, and they have, hundreds of thousands or millions of alerts in the platform, there are chances that your smaller customers may be waiting a really long time before they get another evaluation cycle. And then the last thing we had noticed was that we were duplicating work across a lot of our services. So the alert evaluator and the invoice issuer, for example, they're issuing the same queries to compute billable metrics, but that's double work that we don't need to be doing. So here's our new architecture, and as you can imagine, we had decided that we needed to switch to an event-based architecture, feeding directly off of our event ingestion pipeline. There are I think there are 3 main pieces here that are important. There's kind of the invalidation piece, which tells you, great, what do I need to process, when do I need to process it? There's the actual queuing system, which is the data store and the queuing logic for determining what needs to be processed first. There's the actual processing component, which is on the right in the green. We'll start with the actual invalidation mechanism. So, as you know, we receive events, those events map to metrics, those metrics change quantities. That affects usage and costs, which are the two things we're alerting on. So we decided that when you get an event for a customer, we should probably process that customer. What we had realized was that when you get one event for a customer, you're typically going to get a lot more events for that customer in a short span of time after that. If you think about any sort of D2C product, maybe you're an analytics or a BI tool, you're running a report, right? The first event is not the one you want to be evaluating on. You want to get as close to the last event as possible. So we decided that our invalidation should actually trigger a future processing. We shouldn't do an immediate processing because that's probably going to be wasted work because we're going to have to continually do that for the hour or 2 hours that your job is running. When you have customers that are consistently sending you data, what this does is it allows you to actually just collapse their invalidations into one. So you may not be able to get them, sub 1 minute alerting latency here, but you're saving yourself a lot of work, which is kind of what we felt was more important for the first cut of this process. So the invalidator here, it builds these set of customers that we've just seen events for. It pushes them downstream to a scheduler. The scheduler here has configurable intervals per account, and it will go ahead and schedule a future customer processing for each customer that we sign an event for. That scheduling mechanism itself actually is just a different database table that we had decided would have been a good enough queuing system for our first cut of this project. So then we have the customer processor. So one of the things that the customer processor allowed us to do was actually collapse a lot of that duplicate work we were talking about previously. Instead of having one service that evaluates alerts and one service that evaluates invoices and maybe one service that handles like your pre-purchase balance and stuff, we decided to put it all into one service and reuse the billable metric computations. This saved us quite a bit of work on actual event store query load. So I think that's mainly a rough overview of the architecture. What we have found in terms of wins here, we found alerting latency lag reduced quite a bit. So for customers that were sending us events pretty frequently, like those 100 to 500,000 events a second customers, we've seen about a 60% reduction in alerting lag across our system. For what we call sparse ingestion customers, which are customers that'll send us maybe a few events an hour, and for only a subset of their total customer set, we've seen about a 95% reduction in alerting lag. We've also been able to eliminate the starvation of small accounts in our platform, specifically by tuning that invalidation interval I was talking about. And we've also unlocked new future scaling projects. So specifically, I think one of the things we want to do in the calendar year 2024 is move that billable metric query evaluation into the actual event stream and eliminate having to query our event store altogether to compute those. So we're hoping that'll be able to get us to less than 1 minute SLAs on alerts. I think that's it for me. Thank you all. I think we should... I guess if you have any questions. Yeah.
Yeah, I assume this is super useful for a wide range of stuff that you want to build. Was it easy to kind of build this API of events that map all sorts of use cases? I assume it's very difficult if you're a marketing campaign, you're trying to charge people based on how many email they send versus if you're a cloud provider and you're charging people on how many CPU percent they charge, right? How did you guys find this, take it all together in a sense?
I think one of the abstractions that spot us a lot of mileage is this idea of events and an aggregate query over those events. I think that served use cases across fintech and transaction processing, marketing, and then the sort of transactional emails use case, cloud infrastructure, and the compute use case. So there's definitely some cases where it's not possible to just write a query over the events you have, but in some sense, when we were talking to early customers, that's effectively what they were doing in order to generate their invoices. They would put all their events maybe into Redshift or Snowflake, and then someone unfortunately would have to like stay in a room for 2 days at the end of the month and like hand query a bunch of customer data in order to figure out, okay, here's the quantities I should bill on. And so I think the insight was, okay, well, if such a wide range of industries is doing this, then that is something that we should be able to productize.
So oftentimes with billing, you have policies, right? Like
Yeah.
for instance, this customer is locked into this rate. Everybody else's pricing can change, not this customer.
Yeah.
Right? Do you have, what kind of policy engine do you have built into the system for like the business owners as opposed to the technical guys who are doing the instrumentation?
Yeah, so I guess we have maybe a couple things. One thing is by default, plans are immutable, so you have to explicitly version a plan.
Okay.
And actually, we didn't get to talk about that in the product, but there's this thing I mentioned early on of change management being really hard. So the way we've tried to approach that is make all actions in the product as explicit as possible. So you can't just go and change a metric and now all of a sudden a customer that was being charged in compute one way is being charged in a different way for that same compute. So everything is like pretty strictly versioned, and that's a kind of product feature from a policy perspective, but it's also just a auditability sort of requirement.
Right, but is there any sort of like parent-child relationships you can set up? So like this is a class of billing, everybody inherits this class, you know, and then you can knock out exceptions, things like that.
Yeah, so the way that you model that in the product is you have a plan, which is your template pricing. When you subscribe someone to that plan, they get those prices, but then you can override specific aspects of that plan for that one customer only, and you're able to see the lineage of this customer's on this pricing that came from this standard template, or this customer's just on a standard template. We don't have a lot of like lockdown CPQ type things. I think that's where a lot of the policies generally reside, which is like, you know, you're in Salesforce, your RevOps leader says, here's the discounting that's allowed, here's the deviation from the plan that's allowed. We sync in contract data from Salesforce, but we're typically not the CPQ tool.
Right.
Yeah.
And then the other thing I was thinking about, especially with the AWS people here, is that not all CPUs are afforded the same, right?
Right.
Different regions have different
Right.
pricing. So how do you apply like global pricing schedules on things?
Yeah, so we have this, I can show you real quick, we have this thing that is very, very, very common for cloud infrastructure companies, which is matrix pricing. And so it lets you take a dimension, I don't know if these are great examples, but lets you take a dimension of your event data and build a price table over it. So it's super common for this to be like, region cluster size.
Yeah.
But this is the sort of thing you can do if you like allow things like a group by push down into your metrics layer, because as long as you're tagging your events with cluster, you can price that differently.
Do you dog food it yourself to give you really for your customers?
Yeah, so we track overages, for example. So we typically charge on an events basis, and so we track those overages.
What's
through
been
the
your
platform.
learning since you started dog fooding yourself?
Yeah, I mean, I think like our pricing model is pretty simple so far. So I think a lot of the learnings have honestly just been with customers who are significantly, you know, have made 4 or 5 or 6 pricing changes and have a lot of complexity in their pricing. I think one thing we've learned is just that as much data as we can allow our customers to expose to their end users, the better. So as Arsh was saying, like alerts is a good example of this, but being like we have customer portals where you can just link them out to something that shows them their usage. You don't have to like pull that from our API and rebuild it yourself. I think that's been a very important thing for companies that don't have the like engineering bandwidth to dedicate anything to potentially anything to billing. Yeah.
Is it possible for this to work for, say, payments instead of invoices? So if you've got like a streaming service where you pay out creators based on like how much of their content's being consumed, is that an option?
So in that case, you're paying streamers. I'm trying to figure out what the data model there is, but yeah, like you don't have to generate invoices. Invoices are totally optional. You can just auto charge.
Disperse. So paying out to the streamers.
So like YouTube.
Oh, I
or
see.
Spotify.
Instead of charging, you're paying.
Yeah.
Yeah, we don't support that today. Yeah.
connect the dots for me between, say, cost and pricing. And if
Yeah.
you guys partner with any other cost tools like CloudZero or anybody else to sort of help providers understand this
Yeah.
unit, we're going to charge this much more, but it cost us this much, and we can
Mhm.
break those down and connect those two dots.
Yeah, that's something we've thought about. It's not something we do today. I think people do people do that in the platform in some hacky ways. So for example, you can subscribe every customer to a plan that doesn't generate any invoices but just tracks metrics.
Mhm.
Like if you think about, it's the same event data. You have some list pricing and some internal pricing. The internal pricing is your costs. The list pricing is the thing you charge. So you can kind of model that.
Yeah.
And we do have some features that let you, in general, just like model a version of your pricing, but it's not a super sophisticated cost tracking system. But yeah, I think to your point, unsurprisingly, over the last year, the attention on margins is just not much more significant. So yeah, I think it is a direction that is definitely worth considering for us. Yeah.
Great.
Have you shown this to Corey Quinn, the cloud economist?
No, I think I know who you're talking about, but no.
Have you had some use cases of customers with like super complex sources and like they have maybe hundreds of sources that needs to map into these events in like a precise kind of sequence?
By sources, do you mean like, yeah, maybe.
Let's say I'm a software and cloud provider that sells licenses, but also infrastructure, and I want to unify my pricing about all the different softwares that I'm selling, but also maybe all the infrastructure that I have.
Yeah, I mean, we definitely have customers who are literally billing for 20, 30, 40 SKUs per subscription, so that's common, but it's interesting because I think sometimes people ask that with a perspective of like, how can you help? And I think in a lot of ways, there's just some fundamental business complexity that you can't take away in the modeling. So you kind of just need to support it, but you can't really simplify it much. So I think our goal has always been like, how do we make the core primitives as flexible as possible so that you can model whatever you need to within the platform? And then sometimes we do help people pare down things. I think one pattern we've seen more recently is you'll have these larger companies that are traditionally charging for licenses, but they're adding kind of add-on features that are usage, like an AI feature that's usage-based. And they can start using Orb for a limited subset of their pricing because maybe the rest is, it's 10 years of work has been put on it and like they don't even really want to touch that. They just want to start charging for this new thing in a usage-based way.